discussed the various type of discrete optimization models that we can come across. Okay. Now, as the first and the simplest model that we talk in case of discrete optimization are what we call as the linear programming models. Okay. Now, these linear programming models, as I said yesterday, we would be studying a little bit about. The others, I just gave you a brief idea about what they are and how even we didn't even discuss how they are formed because it's not required in this course. But then I just gave you an overview that we can have such a situation. Okay. Now, but then as I said, just like any other discrete optimization model, even linear programming model must have, I mean, the body of the model must have an objective function. Okay. Because we need the objective, because what do we want to do, whether we want to maximize something, we want to minimize something. So the function that needs to be optimized should be clearly defined, and the objective function must be known to us. The second thing that we must know are the set of constraints. Okay. The limitations under which this function has to be optimized. Okay. And the limitations, as we said, discussed, are going to be defined by the resources. Resources means their utilization, how much are they being utilized, and their availabilities. Okay. How much is a particular resource available, I mean, during the course of time for which we are going to optimize things, right? So, of course, the third that we talked of the other day, which we called as the non-negativity restrictions. So, this is something which has been, you know, incorporated by us because we know that the variables cannot take a negative value. So, in order to ease out the process of solving the problem, we impose this non-negativity restrictions. But even in linear programming models, we may have an unrestricted variable also. So the procedure to solve them is slightly different. So which we would be studying in detail in our next semester when we study linear programming models in details. Okay. But so far we would consider only the non-negativity restrictions. We'll stick to it. Okay. Now, as I said, the thing, this is the body of the model that should look like. Okay. So that means when we are given a real life situation, we have to convert that real life situation into a mathematical model or a mathematical problem whose body should look like this. And then we have to solve. See, the thing is that, like in the very first class, I said we are doing modeling now. Girls, can you please just hold on for a minute? Yeah, sorry. Okay. So, as I said, when we are talking of the situation, when we are modeling, that means what? We have a real life situation. Okay. We are converting this life situation into a mathematical model or a problem. Then we are solving this mathematical model, and then we are interpreting the solution. Okay. Whatever solution we obtain, we interpret that solution into the in terms of the real life problem that was given to us. Okay. So same, that means the very first step when we are actually solving any modeling problem, the first step is what we call as the problem formulation. Okay. How we are forming a problem. Okay. Now for this, I will just see this, you learn right from, say, class 1, or nursery, when addition is introduced to you. Okay. Just a minute, girls. Now, as I was saying, like when addition is introduced to you, no, you learn one part is you learn the mathematics of addition, how to add numbers, right? Now, once addition has been taught to you, just go back to your class one or whatever class in which you studied addition. What was the next thing that was given to you? When you had learned addition and subtraction, then what was the next kind of problems that were given to you? Hmm?
My word problems on addition and subtraction.
Word problems on addition and subtraction. Now, word problems are actually nothing but real life situations, right? Now, when you were given a word problem, so what was the first thing that you used to do while solving it? उसको लिखते कैसे थे?
We write statements.
We write the statements, right? So when you are writing the statements, basically you are converting that real life situation into a mathematical model. Okay. So that means you are actually talking of the problems formulation at that stage. यही करते थे ना? Given this, I mean, you are given this. Okay. So that those statements you have to write. Say, for example, you know, say, for example, say Akanksha has 5 toffees and Ayushi has 6 toffees. So these are the statements that you are writing, right? So that means what? That means you are trying to formulate the problem, or you are trying to write the mathematical model for that problem. Now, once that model has been written, then you solve it. Okay, you solve it. You solve it by using the mathematical techniques that are known to us for that particular situation in which that model is has been constructed. इसी तरह से ही करते हैं ना. Same thing we are going to do here. We are going to formulate the problem, we are going to solve the problem, and then we are going to interpret the problem in terms of real life situations. Okay. Now, for problem formulation, like whatever be the situation given to us, the very first thing that we have to do is identify the decision variables. Okay. That means we have to first of all see what are the decision variables. This I explained yesterday. What are the decision variables? The variables that are going to help us in taking the decisions. Okay. Once we have identified the decision variables, then we have to construct. See, it's a linear programming problem. That means all your functions are going to be linear in nature. Okay. That means whatever are your decision variables. So, see, the moment we identify the decision variables, we'll get to know how many decision variables are there. Okay. So basically, we'll get to know the indices. I mean, how x1, x2. So these are going to be my decision variables. Okay. So I'll get to know the kind of variables that are there in this particular problem. Then, because it's a linear programming problem, so as I said, all the variables are going to be related to each other in a linear manner, both in the objective as well as in the constraints. Okay. Now, then once we have identified the decision variable, then we have to identify the objective. That means we have to identify whether we are going to maximize something or we are going to minimize something. So that means now we are going to classify whether it's a maximization problem or it's a minimization problem, because definitely it's an optimization problem. But even in optimization, we can do both maximize or minimize. So that means now the second thing that we have to do is when we identify our objective, the first thing that we identify is what do we have to do? You know, we have to either maximize it or minimize it. Then we identify the function that needs to be maximized or minimized, or in other words, we identify the function that needs to be optimized. Okay. Then one by one, we identify the constraints. Okay. And this will give us the number of constraints. How many constraints does my problem have? Okay. Once we have identified this, so as I said, non-negativity restrictions, all my xj's will be more than or equal to 0. This goes unset, right? Because we are handling we are handling problems in which all the variables are going to be non-negative. But otherwise, in case, not in this course, but subsequently when you do, you have to identify this also. Are all the variables non-negative? If yes, no problem. If no, then we have to identify which of the variables are unrestricted. Okay, we may come across situations. Okay, we may have problems. So we do have methods to solve linear programming problems where the variables are unrestricted in sign as well. Okay, so that means they can be negative as well. Okay, so that depends upon the situation. But as I said, for us at this moment, this is going to be our non-negativity restrictions. Is this clear? Hmm? Just one yes or no will do. And then we can start with the problem. Huh?
Yes, ma'am.
Okay. Now see, if you see the first problem in your exercise 7.1. Huh? So, I mean, it's a huge explanation which has been given. And we'll construct the model first, and then we'll see how it has to be solved or how it can be solved right now. Okay, so the very first thing is that we first have to solve it, right? I'm sorry, we first have to construct the model. Okay, see, this problem or this situation is a problem of what we call as the resource allocation. Okay, so what is the problem is that it says you have just become the manager of a plant producing plastic products. So that means we have a scenario which is a production scenario, and plastic products are being produced. Okay. Now, the plant operation involves many products and supplies, but we are interested in only three products. Okay, floor coverings. Okay, this is what I'm writing. The products, floor coverings, the output of which is measured in box lots. So that means we have boxes for that. Then the second is the countertop. Okay. And this is measured in yards. Okay. So that means its length or per yard. And the third is wall tiles. Okay. Which are measured in squares. So basically square feet. Okay. These are the three products that we are interested in. Okay. Now see, as I said, your three products, that means the owner of this production unit has come to you. I mean, you are the manager, of course. And then you have to decide, because these are the three products you have identified which need special attention, in the sense that maybe, they are giving you the maximum profits apart from all other products that are being produced, or whatever be the reason, right? But then the purpose of this is that we are handling products together that have totally different units of measurements. So that means for us mathematically, this units of measurements are not, going to be a hindrance to us while solving a problem. So that means the model that has been defined is so good that even if the units of measurements are diverse and varied, there is no difference on the solution procedure. Okay, so because each variable is independent of each other. Okay, they are different, and each variable is treated in a different manner. Okay, so even if we have different units of measurement, it's not going to be a problem to us. Okay, then these are the products. that we are interested in, right? Then the next paragraph, it says, of the many resources needed to produce these products, we have identified four resources. Okay, so these are the products, and now we can talk of the resources. There are four in number that have been identified, namely vinyl, second, asbestos, third is labor, the manpower, and fourth is the time on a trimming machine. Okay, so it's machine. Okay, um, these are the resources that are going to be used to produce those three products, right? But because they are resources, so that means we must know what are the availabilities of these resources. Okay, so it's like it says on a particular day, only 1500 pounds of vinyl are available, right? 200 pounds of asbestos are available. And after talking to various, labor person and all, so only 3% days, that means, of labor are available for use per day. And trimming machine is available for only one machine day on a given day. Okay, so these are your availabilities. Okay, now the thing is that we are talking of three products which need all these four things, right? Now look at the first resource, vinyl. The total is available only for these many pounds, right? But then all those three products require different amount, no, for of these particular raw materials or resources, right? So that must be given the other day. I mean, somewhere here. Yeah. So it's given in the form of a table. Now, those of you who have books, you can say, like, for example, like floor cover. I'll just make the table for the others also. Okay, let's do one thing. I don't want to write everything. Let's do one thing here. Let us call our floor covering by, let us denote X, a floor covering by X1, countertop by X2, and wall tiles by X3. Because if you see in the end, it says formulate a mathematical model to determine how to allocate resources to maximize profits. So when we say, see, it says we have to allocate resources. Allocation of resources means how to optimally utilize these resources for these three products so that our profit is maximized. Okay, so utilization के लिए मतलब क्या हुआ? We'll assume that let us assume that we are producing X1 units of floor coverings, X2 units of countertops, and X3 units of wall tiles on a particular day. Okay, so these are my variables now. So these are my decision variables. So I have how many variables? Three. I have identified those, right? Now, I have four resources, right? So as I said, every resource is going to define a constraint. Okay, so that means the resource vinyl, I mean, the utilization of vinyl and the availability of the vinyl is going to define my first constraint. Similarly, asbestos, labor, machine time, and so on and so forth. So basically, this means what? I'm going to have four constraints here. So that means now I have a problem which has three variables and four constraints. Okay, so one thing is clear in my mind. This is how the variables and the constraints are going to be like, right? Now, as far as the utilization is concerned, see, it's given to me like now I'm writing X1, X2, X3. So you know what is X1, you know what is X2, and what is X3, right? Now, the utilization has been defined for these resources, labor, and machine time. Okay, it's given like this. Say it says I'm writing as given in the problem: 30, 20, 50, then 3, 0, 5, then 0.02, 0.1, 0.2, and machine time is 0.01, 0.05, 0.05. Okay, now this is just like a matrix, See, what does it mean when I say 30 here? That means what was X1? Floor covering, right? So this basically means that 1 unit of floor covering requires 30 units of vinyl. Okay. Similarly, it requires 3 units of asbestos, zero point zero 0.02 units of the labor, and zero point zero 0.01 units of the machine time. Okay. Similarly, the second row would correspond to the second variable, and the third row would correspond to the third variable. So you can see in this matrix, if you read it row wise, you are talking of the products. Okay. And if you read them column wise, you are talking of the resources. Okay. So as it says, the total vinyl is available how much? 1500 units, right? Similarly, asbestos, 200. So these are the availabilities. This is 3, this is 1. So this is the total availability of vinyl, right? Per unit, this is the utilization. So whatever is inside this matrix, these are the utilizations. These are the availabilities. Okay. Then we are also given the fact that 1 unit of floor covering is going to give you a profit of $0.8, right? Similarly, per 1 unit of countertop is giving us a profit of $5, and per 1 unit of wall tile is giving us a profit of $5.5. Okay, this is what the problem says. Okay, so this is the profit, this is the availability, okay, and this is the utilization, right? Now you have to formulate the problem. We are just formulating it. अभी हम solve नहीं कर रहे हैं. We are just formulating the problem. अब problem क्या है? The problem says we have to formulate it and determine how to allocate resources to maximize profits. Okay. So one thing is very clear, that our objective is to maximize what? The profits. So one thing is defined here, that I have to maximize. That was one thing. See, first step was to identify the decision variables. I have done that. Second step was to identify the objective. I have done that. Third step was to define the function that needs to be optimized. Okay. Now, which function do we need to optimize? The profit. Okay. So that means now we need to define what we should be calling as our profit function. ठीक है ना? Just a minute, girls. Gee, I'm sorry. Okay. So we have to identify the profit function. Okay. Now to identify the profit function, see, 1 unit of floor covering is giving us this much profit. And how many floor coverings are we producing? X1. So how much profit can we expect from floor coverings? 0.8 x1. ठीक है ना? Similarly, for countertops, 1 unit is giving us 5, this much profit. We are producing x2 units. So um, once again, you write down the profit function. I'll just be. Hanji. So what is your profit function now? 0.8 x1 plus 5 x2 plus 5.5 x3. Is that right? Now, let us call it say z. कोई नाम तो देना पड़ेगा ना इस function को. And this is my objective, that I have to maximize z. This is clear. So as you can see, this is a linear function. All the variables are degree 1 here. Okay. So this becomes your objective function. Now let us write the constraints one by one also. Okay. How is your constraint going to behave? Now see, just read this. Constraints, as I said, are going to be defined by the resources. So that means to write the constraints, we have to read this table column wise. Okay. Now, what is the first resource? Vinyl. 1 unit of X1 needs 30 units of vinyl. So how many vinyl would be required by X1 units of, what was that? Floor covering. So it will be 30 X1, right? Similarly, for countertop, it will be 20 X2. And for wall tiles, it will be 50 X3, right? So that means the total utilization of vinyl is going to be 30 X1 plus 20 x2 plus 50 x3. Now see, this is going to be the utilization. किसका? Vinyl का. First resource हो गया ना ये, right? On what? On all the 3 products that are under study, right? But the problem is that we do not have more than 1500 units of vinyl, right? So that means this utilization of vinyl cannot exceed 1500. It has to be less than or at the most equal to 1500. इससे ज़्यादा तो नहीं हो सकता. This is my limitation under which I am working. Okay. So that is why it becomes my constraint, right? Similarly, for the second resource, what was that? The asbestos. So it will be, see, now it's see 3x1 plus, now see, what does it say? 0. That means your countertop does not need asbestos, because there is no requirement of asbestos for this, right? So it will be 3x1 plus 0x2 plus 5x3. And this has to be less than or equal to 200 because this is the availability, right? Similarly, the third constraint. Again, it will be read column wise, right? And the total availability is 3. So it will be 0.02 x1 plus 0.1 x2 plus 0.2 x3, and this has to be less than or equal to 3. Similarly, the fourth, the machine days, right? It will be 0.01 x1 plus 0.05 x2 plus 0.05 x3, and this has to be less than or equal to 1. Okay. Now, in this case, since we cannot have negative floor coverings or negative countertops, so we will further write that x1, x2, x3 are more than or equal to 0. Okay. Non-negativity restrictions will play an important role here. Okay, so this is how my model will look like, in the sense that when we write it mathematically, we'll write it like this: maximize z, which you have defined, subject to, this is important because these are the constraint. That means now we'll be looking for x1, x2, x3 in such a manner that the values, when I say looking for x1, x2, that means we'll be finding the values of x1, x2, x3 in such a manner that all these constraints are simultaneously satisfied, number one, and number two, at the same time, that that those values of x1, x2, x3 are going to give me maximum value of z. Okay, so this is how we'll write the problem. So when you say subject to, then you write all the four constraints here, and lastly we write the non-negativity restrictions. Okay, so this is how a typical linear programming problem is going to look like. Is this okay?
Yes, ma'am.